Thank you. Good afternoon. My name is Artur Budzyński. I am a PhD student in Silesian University of Technology, and I would like to present article, The Use of Machine Learning to Predict Diesel Fuel Consumption in Road Vehicles. The main goals of this article first is find methods for preparing data from dirty and rough data from GPS system into useful for machine learning models. Then take some models, compare and find the best with smallest forecast error, and in the end share the code from this project in open access and show possibility of implementation. Scope of work. So first check literature, use fuel forecasting methods which are till now used. Then take 13 machine learning models and test them by 3 successful metrics. Next, save models, give to the models new data and make validation. Then show possibility implementation with creating environment, and in the end, conclusions. Project is made with use programming language Python. Is used in project for create training, testing and validation. And what is important, popularity of the language has been growing in recent years. This you can see, figure shows the number of question tags on Stack Overflow. It's one of the best place where you can ask about code, programming, etc. And also there is many useful libraries for Python created. About software, project is made in Jupyter Notebooks. It's a text editor for project using also a code. GitHub is online open access code sharing website. This project you can also find on this repository on GitHub. You can see now on screen a link to this. Libraries, we use Pandas. It's a library for data processing. NumPy is for numerical calculations, for example, for check success metrics. And scikit-learn is for machine learning. Like I hear from many practice in machine learning is already #1. Data visualization is made with use Matplot library. Preparing data. We have data from GPS system from transport company which has in fleet 40 tons trucks. They work in international transport in Europe. Data are divided into 3 categories. First is depending from way. We have here data when it was transport distance, cargo weight, start place, and delivery place. Second category is about truck. We have here a vehicle power, engine capacity, vehicle mileage, vehicle ID, vehicle production year, vehicle weight, and max vehicle weight. The last is depending from characteristic of the driver. Here is driver ID, driver age, and driver quantity. It's showed here preparing data. It's really simplified. In practice, it's more complicated, and feature engineering is bigger. It's simplified here. Which models we tested? There is 13 models divided into 5 categories. First is category classical regression. We have here linear regression and ridge. Second, with variable selection, we have a model lasso, LARS, Lars, IC, Elastic Net, OMP, and OMP cross-validated. Next category, Bayesian, is Bayesian rich and ARD regression. Next category, outlier robust. We have here a ransack regressor, and the last category, GLM, here a 2D regressor. How check which model is better? We take three successful metrics: is popular mean square error, root mean square error, and coefficient of determination. You can see here a pattern for all testing. For testing, data are taken from start May 2020 to the end of May 2021, so we have a full year. Data are divided into 70% training and 30% testing set. You see here a score of these models. Then all models tested are saved, and we gave them a new data from June 2021, and results of the validation is shown here. The best is Lars model. About conclusion, so machine learning can be used successfully to predict use fuel in trucks. Lars is the best model in the study. All software used in this project and shown here is free and in open access. Data code models are available on the project website on GitHub. You have here also a link. You can take this model, test with your data. Also, it's shown here how step by step create environment to repeat this experiment and this project or similar. This model for prediction can be used independently or can be used in other complex methods. This allows you to make the right decision in road vehicle fleet management, and you can save in companies money and reduce negative impact on environment. Thank you for attention. You have here a contact to me. Thank you.